Question number 1. Select correct direction of angular velocity for a body performing uniform circular motion. There are the 4 options given. We have to select one correct figure showing correct direction of uniform circular motion and direction of angular velocity. Let us discuss the solution. The option C is correct. How the option C is correct? Let us discuss. To answer this question, we need to know right hand thumb rule. The direction of angular velocity in case of circular motion along the axis of rotation is given by right hand thumb rule. In figure 1, the body performing circular motion, the curled fingers give the direction of circular motion and the thumb showing you the direction of angular velocity. And in case of second figure, the body is moving along the direction of curled fingers and the direction of angular velocity is in the downward direction. Therefore, curled fingers of right hand gives sense of rotation and outstretched thumb gives direction of angular velocity. Therefore, option C is correct. Question number 2. In case of UCM, the acceleration directed toward the center is. There are the 4 options. First is the centripetal acceleration. Option B, A equals to V square upon R equals to omega square R equals to V omega. Option C, along negative vector. And option D, all. Here is the correct answer is D. Let us discuss the solution. This is the circular path and it is the radius R, and this is the body performing circular motion. If you consider the different points of this circular motion, the linear velocity always along the tangential direction. The linear velocity always tangential to the path of its circular motion. And centripetal or radial acceleration, it is also called radial acceleration, centripetal acceleration or radial acceleration. So centripetal acceleration is denoted by vector AR. It is given by minus omega square into vector R. The magnitude of centripetal acceleration is equals to omega square into R. We already know V equals to R omega. Therefore, omega equals to V upon R. So the same formula becomes V upon R whole square multiplied by R equals to V square upon R. This can also be written as omega into omega R, that is equals to V omega. Therefore, option B, A equals to V square upon R, omega square R equals to V omega is correct. And the centripetal acceleration, that is directed toward the center. Therefore, it is in the direction of negative vector of radius. Therefore, option C is also correct. And it is also called centripetal acceleration. Therefore, option A is also correct. Therefore, option D, that is all options are given correct. Therefore, we finally lock the option D. Question number 3, centripetal force. Option A, responsible for circular motion. Option B, directed towards center. Option C, centripetal force equals to minus m omega square into vector R. Option D, all. Here is the option D correct. How option D correct? Let us discuss. We know that force equals to mass into acceleration. Therefore, F equals to m, and acceleration nothing but centripetal acceleration, that is minus omega square R vector. So that is equals to minus m omega square vector R. So option C is correct. Now centripetal force. There are the two forces acting in the circular motion. One is toward the center, another is away from the center. One which is toward the center is called centripetal, and the force away from the center is called centrifugal. Since centripetal force is having the direction in the negative r, therefore centripetal force equals to minus omega square r is correct, and directed toward the center is also correct. And centripetal force always responsible for maintaining circular motion, therefore option A is correct. Therefore option A, B, C correct, therefore we select all options are correct. Option D is correct. Question number 4. On horizontal circular road, option A, normal reaction and weight of the body balanced. Option B, force of static friction balanced by centrifugal force in magnitude. Force of static friction balanced by centripetal force in magnitude. Option D, all. Now let us discuss the solution. It is a horizontal road. It is not banked road. And on this horizontal road, the car is moving. In case of horizontal circular motion, the normal reaction is balanced by the weight of the body. Therefore, mg equals to n. Here is option A, normal reaction and weight of the body are balanced. So this is the first condition for horizontal circular motion. Normal reaction is balanced by the weight of the body. And force of the friction Fs equals to magnitude of centripetal force. Magnitude of centripetal force and magnitude of centrifugal force are equal. Only difference between centripetal and centrifugal force, they are in opposite direction. The magnitude of centripetal and centrifugal force are equal. Therefore option B and C also correct. Therefore all options are correct. Therefore we lock option D. Can you guess? The next question is related to well of death. So next question is going to be very interesting. I hope you can answer the next question. So what is the next question? Let us see. In all competitive examinations, sometimes the questions are twisted, and many of the students, they mug up the options, they mug up the tricks, they mug up the formulae. This will not work to score high in the examination. If you want to really score more marks in examination, like NDA, engineering CET, IIT JEE, NEET examination, then you must read the textbook very carefully, because the questions always frame from the textbook. They are not outside the textbook. Now this is the question is from inside the textbook. Who had studied the textbook lesson carefully, that fellow only can answer this question. What is the question? For a well of death, normal reaction is directed in horizontal direction and always away from center. Option B, normal reaction is directed in horizontal direction and toward the center. Option C, normal reaction is directed in vertical direction and always away from the center. Option D, normal reaction is directed in vertical direction and always toward the center. Which option is correct? Can you guess? Let us discuss the correct option. In case of well of death, there are the three forces. One is the normal reaction, second is the weight of the given vehicle or body, and the third one, the force of static friction. And the force of static friction is balanced by weight of the body. And normal reaction is in horizontal direction, and it is balanced by the normal reaction. In case of well of death, normal reaction is acting horizontally and it is toward the center. Therefore, in case of well of death, normal reaction directed in horizontal direction and toward the center. Therefore, option B is correct. We lock the option B. There are the two types of roads. One road is called unbanked road. Unbanked road are roughly horizontal road. And the second type of road are called banked road. In case of bank road, outer surface of the road more heighted compared to inner side of the road. It is little bit tilted by an angle theta. Such type of roads are called banked road. Banked road are designed for the safety of the vehicle. The next question is based upon the banking of the road. Question number 6. For banked road, the most safe speed is R is the radius of circular path, M is the mass, G is the acceleration due to gravity, theta is the angle of banking, N equals to normal reaction. Option A, V equals to under root of mg tan theta. Option B, V equals to under root of mg tan theta. Option C, under root of rg tan theta. And option D, none. We have to select one correct option. Here is a diagram for angle of banking for a car taking a turn on a banked road, where theta is the angle of banking. N is the normal reaction. The normal reaction having two components. One is the N cos theta. This is vertical component. And N sin theta, that is horizontal component of normal reaction. So horizontal and vertical component of normal reaction. Now vertical component N cos theta is balanced by weight of the body, so N cos theta equals to mg. And horizontal component N sin theta balanced by centripetal force. So we got equation 1 and equation 2. Dividing 2 by 1. After dividing, we get V equals to under root of Rg tan theta. Therefore, option C is correct option. We lock the option C. Question number 7. For a conical pendulum, frequency of revolution is given by if gravitational acceleration equals to length of pendulum and theta equals to 60 degrees. 4 options: pi root 2 hertz, option B root 2 hertz, option C pi upon root 2 hertz, and option D 1 upon pi root 2 hertz. For conical pendulum, the frequency of revolution is given by N equals to 1 upon 2 pi under root of G upon L cos theta. Given G equals to L, therefore N equals to 1 upon 2 pi under root of G, here I can write L and here also L, and theta equals to 60 degree, so cos 60 degrees. This is equals to 1 upon 2 pi, L and L get cancelled. So we get here root get cancelled, N equals to 1 upon pi root 2 hertz. So option D is correct. So we lock the option D. Question number 8. For a vehicle on a convex overbridge, speed at the uppermost point is obtained by using relation. So there are the 4 relations are given. We have to obtain the correct relation, so that by using the relation we can obtain the speed at the uppermost point. Let us discuss the solution. When a vehicle is moving on the convex bridge at uppermost position, the normal reaction is in the upward direction and the weight of the body in the downward direction. So total force acting on the body at uppermost position is mg minus n. This has to be balanced by the centripetal force. Therefore, the relation is mg minus n equals to mv square upon r. So we lock option B. Option B is the correct option. Mg minus n equals to mv square upon r.